In this video, we're going to solve systems of equations by graphing. For our case, our system will be made up of two linear equations. But before we get into that, we just want to review how to graph a linear equation. You've learned two methods to graph. The first was by plotting points. So let's see if we remember how to do that. What I'm going to do is graph this linear equation, 3x minus 6y equals negative 12, by finding points. And we did that by organizing our work in a chart. And the points I like to find are the intercepts if I can. Okay, so this means plug in 0 for x right here, solve for y. That's the x-intercept. Or I'm sorry, that's the y-intercept. When we plug in 0 for x, solve for y. We like 0 because that happens. 3 times 0 is 0. And I'm left with negative 6y equals negative 12. Divide both sides by negative 6 to give me a y value of 2. Do the whole thing over again. Plug in 0 for y to find the x-intercept. 3x minus 6 times 0 equals negative 12. That goes away. 3x equals negative 12. Divide both sides by 3, and x equals negative 4. Okay, x equals negative 4 when y equals 0. So I plot those 2 points, 1, 2, 3, 4, negative 4, 0, and 0, 2, and I have my line. That was one method you learned. Now, the other method you learned, if you're given an equation in this form, or you could put, for example, I could put this equation in slope-intercept form, which is how this one is given. There's the slope. The slope is right here, right? And this is the y-intercept. Okay, and these ones are maybe easier to solve. You just identify the y-intercept, which is right here at negative 1, and you see that the slope is 2/3. So that means you're going to go over 3 and up 2 from that point. Over 3, up 2. All right, and there's another point, and there's your line. Okay, so why are we reviewing that? Because we need to solve a system. So here's the new part. So we're going to solve a system of equations. So you'll notice you have two lines here. Okay, so for all these problems, we'll be graphing two lines, and the solution is going to be an x and a y value that not only satisfy this first equation, but an x and a y value that also satisfy the second equation. Okay, so we're going to learn ways to do that algebraically, but first we're going to do it graphically, since basically we already know how to do that. So I'm going to graph the two lines. Okay, so I'll use green to graph this line. So it's really two problems in one. So I'll do the same thing that we just did when we were reviewing. I'll plug in 0 for x, and I'll solve this equation to find the x-intercept, the y-intercept, I'm sorry. 4 times 0 is 0, so I get 2y equals 8. Divide both sides by 2, and I get y equals 4. So there's the y-intercept. I'm going to do that all over again to find the, I'm still just working with this first line right here. 4x plus, and then I'll plug in, of course, 0 for y to find the x-intercept. All right, that goes away. 4x equals 8. Divide both sides by 4, and x equals 2. Okay, so there's one line. What I like to do is just treat it as two problems. So I'm going to graph my first line, 0, 4. You got to be real careful when drawing your line, 2, 0, because the point at which these two lines meet will be our solution. So if we're not careful with our lines, then we might be off a little bit with our solution. Okay, so there's my first line. So like I said, it's two problems in one. So now I got to do the whole thing over again. Okay, so what I'm going to do here is graph the other line. All right, so once I graph the other line, then I'll just have to find the point of intersection. So let's go ahead and graph that one. So negative 2x plus y equals 0. So again, I'll organize my work in a chart. And I'll plug in 0 for x to find the y-intercept, 0 for y to find the x-intercept. Negative 2 times 0 plus y equals 0. So that goes away, and I get y equals 0. Okay. So in this case, the x and y intercept happen at the same place on my graph that's right here at the origin, 0, 0. So when this happens, what we have to do is find another point, right? Because obviously if I plug in 0 for x, I'm going to get 0 for y. That's the same exact point. All right. So what I'm going to do here is pick some other value. Now you can pick whatever you want. It's whatever you think is going to be easiest. I'm working with this equation. I can see if I plug in 4 for y, let's see, I'll get a nice integer for my solution. See, I picked 4 for y because I know I'm going to have to subtract 4 over to solve this equation for x. So that leaves me with negative 2x equals negative 4. Divide both sides by negative 2, and I get an x value of negative 4 divided by negative 2, x equals 2. So I found one more point. That's the point 2, 4, and I graph that second line. Okay, so really, that's nothing new. What we did is we just graphed two lines. There should be straight lines. Here's the new part. The solution to this system is the point, okay, where these two lines intersect, and that's this right here. That's the solution to this problem, the answer to the question, and that's the point, what, 1, 2, x value 1, y value 2. That point, if I plug a 1 here, a 2 here, you can see satisfies the first equation, and it also satisfies the second equation. That's the only point that should satisfy both of those if you want to check your work, which you should do. Okay, but here I can see my solution on the graph is 1, 2.